Okay, here's our video on closure, right? And we're not talking about any kind of personal situation like in psychology or something. We're talking about math, closure in math, right? And we're talking about the properties of this symbol, which is real numbers. Real numbers, as opposed to fake numbers, right? Fake news. Anyway, real numbers you should be used to by now. They're every number you've pretty much used your whole life, right? Integers are real numbers, fractions and decimals are real numbers, and rational and irrational numbers are real numbers, as opposed to imaginary numbers, which we will talk about in another video. And imaginary numbers are not actually fake. They're not imaginary. It's just what they're called. But again, that's a different video. We're just going to talk about real numbers. So that's the symbol. Fancy R. Again, real numbers. Let's put our categories. They could be integers, right? We know what an integer is. Any number that's not a fraction or a decimal. There's the symbol for integer. The Z, Zahlen, German word for number. Right, they can also be fractions, right? We have fractions. As my hand blocks the view. There we go. Fractions. We know what a fraction is. And put another line, they could be decimals. It could be decimals. Right? Integers, fractions, decimals. And this whole thing, we'll just bring this up a little more. There we go. This whole set right here, subset, really, is under a heading of rational numbers. Rational numbers. And the symbol for rational is Q. Rational numbers. Okay. And there's also irrational numbers. So that's another set. So we have our real numbers, which we talked about, the real number systems, and they could be rational or irrational. Sometimes people put this little thing up there indicating irrational. Right, so this is the rational numbers. And you know this already. And irrational. Right, and so irrational numbers we know are like pi is irrational and square root of 2. Those are probably famous ones. And phi is also irrational, the golden ratio. Irrational, not rational. We'll talk about irrational numbers in another video. But for rational numbers, they have to be in this form, a over b. And b cannot be 0. Can't be 0. If it's 0, it's undefined. So all rational numbers, Q, right? All rational numbers, not R, that's real. But what rationals are, if we can get this thing open, it's stuck today. There we go. Wow, that was stuck. So if we have the rationals, we're saying that they have to be A over B, and A over B have to be numbers, right? Any whole numbers. But B can't be 0 because we said if B is 0, it's undefined. So when you make these whole numbers, they have to be made into a decimal. So any fraction could be made into a decimal. And here we go. It's 0.4. 2/5 is 0.4. Now the decimal has to do two things. Here's two rules. We'll put some bullet point. It has to either terminate. Right? It has to terminate. Means it has to end. Right? 0.4 ended. That terminated. Or it has to repeat with a pattern. It has to have a pattern. So, like phi repeats, but phi and pi don't have a pattern as yet, right? They're still trying to figure that out. So, for example, right, let's move this up, bring this up here. If I said 3.3 with a line over it, well, that repeats and it has a pattern. 3, 3, 3, 3, 3 forever. If I said 3.25, 25, 25, and it's just going on 25, 25, I can just say 3.25 with a bar. And again, there's the pattern, 25, 25, over and over again. So we know it will repeat with the 2, 25, 25, and so on. So it's rational. They're all rational numbers. So one that appears, and some people get tricked on, is this one. If I said 0.01, 001, 0001, 00001, bring that over. Now you can assume, and we'll put the ellipsis here, that There's going to be, the next one will be 0, 0, 0, 0, 0, 1. There'll be 5. Well, that's true. It is repeating, but not with a pattern. There's no pattern here. It doesn't go back to that. So since it doesn't go back, even though the numbers keep repeating forever, and even though you think you see a pattern, the pattern doesn't repeat. That's the real key. The pattern has to repeat. The pattern has to repeat. Right? If the pattern doesn't repeat, then it's irrational. So again, there is a pattern. You're assuming, okay, I see the pattern, but the pattern didn't repeat. Even with shapes, if you have a triangle, then a square, and a circle, then you have a triangle, a square, and a circle. Well, you can see that the pattern is repeating. Right? But if it's not repeating, like if you have a triangle, you have a square, you have a circle, then you have a circle, and a circle, and a circle, and there's no pattern here at all. Right? But let's say you saw some form of pattern. You saw a triangle, circle, triangle, triangle, square, square, circle, circle. Well, you can see there's some kind of pattern developing, but it's not repeating. Okay, so let's talk about closure now. That's the real thing we were going to talk about today. The real thing, get that? Real numbers. Closure. And let's look at one, for example, with whole numbers. So if you take a whole number, anything from 0 to 1 is a whole number. No, 0 to infinity, I'm sorry. They're whole numbers. And they can't be fractions or decimals. They're just integers. So if we take 1 and we add it to 2, we'll get, guess what? We'll get a whole number. So if you're adding whole numbers, you'll get a whole number. That means that the set is closed. The set of whole numbers under addition is closed. Your answer is also a whole number. So if we had a set of whole numbers and you added them, you get a whole number. Let's check again. What if we had 7 plus 12? They're both whole numbers. What's your answer? 19, right? So, and 19 is a whole number. So it's closed. So under addition, whole numbers are closed. But let's try subtraction for whole numbers, and then you can understand closure a little better. So let's try whole numbers with subtraction. If I did 7 minus 3, well, we get 4. Well, it seems like it's closed. But what if I did 7 minus 9? I'll get negative 2. That is not a whole number. Negative 2 is an integer, but not a whole number. So under subtraction, whole numbers are not closed. They're open. So if it's not closed, it's open, like a door. If it's not closed, it's open. Simple as that. So again, under addition, they were closed. Under subtraction, they were open. What about multiplication? Doing whole numbers. Well, again, if I did, let's say 7 times 2, we get 14. Is that a whole number? Right. Now, we can't do 7 times negative 2 because we said we're only going to use whole numbers. Right? 7 times negative 2 is negative 14, but again, we said we have to use a set of whole numbers. These are not, so that wouldn't count. So if you took any whole numbers and multiplied them, you would get a whole number. So again, under multiplication, it's closed. But under division, well, 8 divided by 2 is 4. That works. But 2 divided by 8 does not give us a whole number. Right? Because this is 0.25 or 1/4. Right? So this is not a whole number. So under subtraction and division, whole numbers are not closed. And you can check for the rest. You can check on even, we'll do one more, we'll do real numbers. Well, real numbers are easy. Everything's closed on the real numbers. If you took any set of real numbers, they will be closed in all the operations. Rational numbers, though, could be interesting. So rational numbers, we said we use a Q. So if you took any rational numbers, you should get a rational number. Right? So if I took a rational number like 1/4 and I added it to another rational number like, let's say, 3, well, my answer will be a rational number. So that's what closure means. If you take any set, any numbers in the set, and your answer is still in the set, it's closed. If it's not in the set, it's open. So again, with subtraction, I said 7 minus 3 is 4. But you can't just assume this is open or closed, because I didn't tell you what this was yet. If I say, well, these are whole numbers, well, 7 and 3 are whole numbers, and the answer is a whole number. 3 is a whole number, 7 is a whole number, but the answer is not a whole number. Okay, so that's closure. Great job.